Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on coin change. It's a very popular problem asked in multiple interview questions, and also we are going to solve it using dynamic programming. Okay, let me just jump into the problem statement, explain the problem and start coding, right? Okay, so last time we solved implement try prefix tree. You can find it in the list. Let's start with coin change. Okay, this is a very frequently asked interview question, as I mentioned. Apart from that, this is actually a really interesting problem. Okay, so you are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by the combination of coins, return -1. Okay, you may assume that you have infinite number of each kind of coin. Okay, so firstly, one thing, please don't mind my voice today since I have got some cold. Okay, let's understand. So let's say we have these set of coins 1, 2 and 5, and we can have infinite number of coins of each denomination, and we have to form number 11, amount 11. So can we make 11 out of these set of coins? So yes, we can have two 5 rupee coins and one 1 rupee coin, right? Similarly, we could have had 5 2 rupee coins and one 1 rupee coin, or we could have had simply 11 1 rupee coins. So it's possible, and the minimum number of number of coins to make this sum is 3 if we go with 5 plus 5 plus 1, but we can go with 2 plus 2 plus 2 plus 2 plus 2 plus 1 as well, right? But the minimum one is this approach, so the solution is 3. Similarly, we have coin 2 available, amount is 3. We can never make 3 out of coin 2 because if we keep only one coin, the sum would be 2. If we keep 2 coins, sum would be 4, which is greater than 3, right? So we have to solve this problem. Before we start solving, please take a minute and think of a solution approach. Okay, there is some flying going around, so there are a lot of airplanes flying around right now. Okay, so before we start solving, let's understand it this way. How we can solve it, one is that we find out all the permutation combination, so that would be the brute force attack, but we do not wish to go with that. We'll be using dynamic programming. Now how we are going to solve it is, let's say the asked amount is 11. Okay, we'll create an array of the amount plus 1. So I'll create an array of size 12, and let's say I'll initialize each solution so by a number bigger than the amount. I can initialize it with 100 or anything. I'll just initialize it by amount plus 1. So I'll initialize 12 12 12 12 12 12 12 12 12 12. Let me explain why am I doing this. So we have 4, then 4, that is 8 9 10 11 and then 12. Okay, since the asked amount is 11, so the first is for 0. This is 1 2 3 4 5 6 7 8 9 10 11. Now imagine solving the problem like this. What if we were asked to create the amount 0? How many coins would we need? We would need 0 coins, right? So we have the solution. Now if we were asked to create the amount 1, so this is being represented by the index 1 2 3 4 5. Okay, we are going to go for 11, but for the initially we'll initialize them with some bigger value, so that's why we have initialized them with 12. Okay, because easily we can use 1 rupee coin for each one of them. So if we have to find out how many coins do we need minimum to create amount 1, and let's say we have only 1 rupee coin, so we need 1 coin, right? So we can make this one in 1 coin. we can make a 1. Similarly, with 2 coins we can make a 2, and similarly this 3 can be made with 3 coins, 4 can be made with 4 coins, 5 can be made with 5 coins, 6 can be made with 6. Similarly 7, 8, 9, 10 and 11. Now this was that we were considering that the available coins is only one denomination is available, okay, out of this 1 to 5. Now let's say we consider that okay, now 2 is also available, okay. So since 2 is there, we cannot change any value which is before 2, because we cannot form 1 using 2 coin, right? So let's directly start from 2. So if we have 2 rupee coin, we can make the sum in just one attempt, because we have the 2 rupee coin, right? We can make 2 in just one attempt, okay. Let me put a number over them to represent the indexes and the values of the amount. So 0 amount, 1 amount, 2 amount, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay. So 2 can be made in just with 1 coin, that is 2 rupee coin. Similarly, when we are going for 3, okay, we'll go 2 step back. So 3 minus this coin, that is 2. 3 minus 2, 1. So we know that up until this point we could have made 1 with just one attempt. So if we have to make 3, we just add this 1 coin, right? So whatever was the solution up till here, we'll add 1 to it. So 3 can be made in 2 coins, 1 and plus 1 for this coin, 2. Right, this is actually dynamic programming, where we are using pre-computed solutions to find the next solution, okay. So now similarly, when we are at 4, we will check 4 means this minus the number of the value of the current coin, 2. So 2 step before, we could have created 2 using only 1 coin. Now we want to create 4. We'll take this solution, add 1 for this coin, so we can reach 4. We can make 4 in 2 coins. Similarly, we'll do it for 5. We'll go 2 step back, 2 was the solution, this one would become 2 plus 1, 3. For 6, 2 step back, 2 was the solution, this one will become 3. For 7, 2 step back, 3, this will become 4. Similarly for 8, it will be 4. For 9, it will be 5. For 10, it will be 5, and 11 can be made in 2 step back, 1, 2, 5 plus 1, 6, right? How can we make 11 in 6 attempts? If we have only 1 and 2 coins, we'll use 5 2 rupee coins and 1 1 rupee coin, okay. Now we have 5 rupee coin also, so we'll directly start from the 5th one. We'll change it to 1, because we can use only 1 5 rupee coin and the solution is possible. Now we want to make 6. How will we form 6? We'll subtract 5, the value of the coin, from here. So we subtract 5, 1, 2, 3, 4, 5. That means 1 could have been made using 1 coin. So 6 can be made using that 1 rupee coin plus 5 rupee coin. So solution would be 1 plus 1, 2. Similarly for 7, we'll go 5 step back, 1, 2, 3, 4, 5. 1 and 1 coin for 5, so 2. Now for 8, we'll go 5 step back, 1, 2, 3, 4, 5. That means 3, it was possible to make 3 using only 2 coins, right? That was the best optimum solution. Now to reach 8, we'll add 1 5 rupee coin, and directly we can make it in 3 attempts. Similarly for 9, we'll go 1, 2, 3, 4, 5, 2 plus 1, 3. For 10, we'll go 5 step back, 1, 2, 3, 4, 5. We were at 5. 5 could have been made in 1 coin. Now we want to make 2. Now we want to make 10. We'll add 1 more 5 rupee coin. So it will be made in plus 1, 2 attempts. For 11, we'll go 5 step back, 1, 2, 3, 4, 5. 2 was the last answer to solve 6. Now this would be 2 plus 1, 3. And this will be our solution. If you see 3. right? So we have already done the dry run and how dynamic programming is going to work. Okay, now we are going to solve the same in the code. So please stay tuned. Let's start coding. Okay, let's create the array where we are let's create the dynamic programming array where we are going to store the values. So create an array to store the minimum number of coins needed for each amount, right? Now asked amount is 11, so we'll create for one extra, right, for 0 amount as well. So we'll say int, let's call it dp so that we know it's a dynamic programming problem statement. New int, we'll say amount plus 1, right? Now first we'll initialize all the values with a bigger number. So we can initialize with 100 or anything, a number that is not the solution. So since asked amount is 11, 12 is not the solution, so we can simply initialize it accordingly. So we'll say initialize the array with the value greater than the maximum possible number of coins. Maximum possible number of coins would be amount, right? Using 1 it will be 11, so we'll initialize it with 12. So arrays dot fill dp amount plus 1. Now all the arrays initially, as we have seen, right, they are initialized with the value 12. Now we'll change the value for the 0th position, because how do we make the amount 0? Using 0 number of coins. So we'll say the minimum number of coins needed to make 0 is 0. So we can say dp of 0 is equal to 0. Now we'll start with the iteration. So iterate through each coin denomination, because first we started with having only 1 rupee coin, then having only 2 rupee coin, then having only 5 rupee coin. So there is a for loop for this. Then we went through all of this, right? So there is a for loop for this as well. Overall time complexity, if you see, would be O of n, and denoting number of coins, into amount, right? So we'll say for int coin from coins, we'll update our dp value. Update dp array for each amount from coin to the target amount. Why from coin? Why do we update from coin? Because when we have a 5 rupee coin, we don't have to check for the values before that. We'll directly start from 5, because we cannot make any update for 4 rupees, right? We cannot use 5 rupee coin to make 4. So we'll say for int I is equal to coin. We'll start with the coin value. I is less than equal to amount. So we'll go till 11, I plus plus. Okay, now simply, as we had seen, right, that when we are at 5, when we are going for 6, we'll check 5 step before, then we add, right? That is the formula that we were forming. Okay, so the formula is dp of I is equal to math dot min of the current value. So dp of I, let's say using 1 rupee coin we have found a better solution, so why change it with 5 rupee coin, right? So original solution could be better. So minimum of dp of I, or dp of I minus coin. So we are at 6, we do 6 minus 5, 1 2 3 4 5, 1. The solution was 1, and then we add 1 to it to reach 2, right? So dp I minus coin plus 1. That is the formula. That's it. That is the formula that we were trying to create here, and this is actually the whole solution. All the rest of the code is just around it. This is the main part of the solution. Okay, let me comment it for everyone. So dp of I minus coin plus 1 represents the number of coins needed for the remaining amount after using a coin. Okay, so this is the remaining amount. Okay, this is the final actual solution, because when we are at 6, I'm going to repeat it again. When we are at 6, we remove deduct the coin amount, that is 6 minus 5 1. So now we know that at 1 this was the original solution. So if from 6 I remove this amount 5, for 1 the solution was already 1. Now I will add just 1 to the solution, because I can use 1 5 rupee coin and I'll reach 6, right? That's it. So once both the for loops are done, we can return the last index, right? So we'll say or we'll check, there is a possibility that this value is not updated yet, right? Because it's possible, right, that we are not able to form this value, and in that scenario we have to return -1. Now how will we find out? We already had initialized it with the amount greater than the solution, right? So we'll check if dp amount, that is the last index, is still greater than amount, because if you see we had initialized them with 1 greater than the amount, is still greater than the amount, it means this value last index was never updated. That means the solution does not exist. It means no combination of coins is possible. So we'll say return dp amount. If it is greater than amount, we are using the ternary operator, will return -1. If not, otherwise we'll return dp amount. That's it. Okay, remember, reaching this formula is the main part of the solution whenever you are working with dynamic programming. I'll be creating a separate series on dynamic programming later on, but right now in our grind 75 list, whenever we come across dynamic programmings, we have to first find out what is the formula. Okay, we actually have to find out the pattern like we did and then made it into a formula. Let's run it. Okay, let's submit. Since we are using dynamic programming, our solution should be much faster, though the time complexity might look like O of as I mentioned, O of n into amount. So yes, beats 99.92% of the users. So you can solve it without using dynamic programming as well, but I suggest dynamic programming is the best solution. And plus, if you see, it's the easiest and the very less line of codes as well. Yeah, so that's it from today's video, everyone. For anything, please let me know in the comment section, and at the end, please like, share and subscribe. Thank you.